Okay, so I'm going to copy this into, okay, let's see how it goes. Okay, so when you copy, this thing copies pretty badly. It's not copying right into cells. So what do we need to do? Okay, do you know how to splice the data into individual cells? No? Okay. See, when you have, do you see the problem here?
Yeah, like it should
Okay.
have over.
Yeah, see, this thing, the whole thing is in one cell. You want these numbers to be separated into individual cells. So what you need to do is to highlight the range where you have the text data all jumbled up, okay? Then go to data and you have text to columns, okay? And text to columns will give you two options, okay? Either you can splice them up with fixed width, okay, or you can do it by delimited. If it is fixed width, then it will give you where the splicing will happen, okay, and you can go and control that, okay. And sometimes that may not be possible because the numbers may not line up because you're using tab or whatever. So if it has a delimiter between the numbers, either a comma delimited or tab delimited, then you can use delimited and then use any one of those delimiters, okay, and if it is completely different delimiter, you can choose your own. For example, if it is delimited by a slash, then you can use the delimiter like that. I think this one is tabbed, I think. Let's see what happens when you use tab. Okay, nothing happens. So it is not tab delimited. So the fixed delimiter, fixed width works here because you don't need that. So take that off. All right. So now you finish. Everything will splice up, and you have everything nicely available to you. Now we can choose. All right. So now these are the 6 numbers that you need. So I'm going to copy paste that over there, and then I will put the borders back. Okay, when you do this copy pasting, the formatting may get messed up, so you need to make sure that you put the formatting back up. So now mean square is sum of squares divided by degrees of freedom. Okay, so that's your mean square. So that's your mean square. Copy that. So that's your mean square error. That's your mean square regression. Okay. You don't need mean square total. You don't need that. You don't use it for anything. Now the F is MSR divided by MSE. Okay. Now the p-value can be found using the f_dist function. So f dot dist RT, okay, it's f distribution is only the right side distribution. So that's your f value, comma degrees of freedoms are these two, the numerator degrees of freedom and the denominator degrees of freedom. So this will give you the p value. Of course, it's a very small number, and that's why you see 0. It's not equal to 0. It is a very small value. So for 726, it's going to be lots of decimal places before you will get a significant value. Okay. So based on this, can you say the model is significant? The model is significant here means what? So if you go back to the model here, so that one. Okay, so we have 13 of these x's. So we have 13 slope coefficients. So all all 13 of the slope coefficients are equal to 0 is a null hypothesis. At least one slope coefficient is different. That's your alternative. Okay. So here, with this, what we can say is model is significant. Is model is significant or not? Yes, it is significant. Why it is significant? Because p-value is less than or equal to 5% is the normal level of significance used. So what does that mean? So this means, okay, I'm going to insert a row, maybe a couple of rows, so we can describe what this means. This means the at least one of the 13 slope coefficients is not equal to 0. The probability this conclusion is wrong so that is your probability of type 1 error is very close to 0. So that's our p-value. P-value is that probability. So since the probability is so small, the probability of committing type 1 error is so small that we can go ahead and reject the null hypothesis that all the slope coefficients are equal to 0. So at least one is different from 0. So how do you find r squared?